Hello everyone. In the previous video, we talked about joint probability and joint distribution functions, and in this video, we will try to solve a problem to solidify our understanding of what joint probability function is and how we can solve these kind of problems. So the problem states like this. We have the joint probability function of two discrete random variables x and y, and it's given by this expression here, and it's non-zero when x lies between 0 and 2 and y lies between 0 and 3, otherwise it's 0. And x and y here can assume all integers. What we are interested in is to find the value of the constant c in this expression. So that's part 1 of this problem. In part 2, we will try to find the joint probability when x is equal to 2 and y is equal to 1. And in part 3, we will again try to find the joint probability when x is greater than or equal to 1 and y is smaller than or equal to 2. So let's see how we can solve this problem. So the first part of this problem is finding the value of the constant c, and just to remind you, this is the joint probability function. In the previous video, we talked about the joint probability table that makes solving this problem much easier. So let's look at the joint probability table once again. And for this problem, this is how the joint probability table looks like. So we have the x and y random variables, and these are the integer values both x and y can assume. And in the middle we have the joint probability values, and along the margins we have the marginal probability, and then we have the total probability, which is the sum of all the joint probability values or sum of the marginal from x or from y. Now we can solve our question very easily because now we have the total probability value, and we know that this total probability value must be equal to 1. So we can equate 42c is equal to 1, and from here we can find the value of c, which is 1 by 42. Let's see part 2, which is about finding the joint probability when x is equal to 2 and y is equal to 1. Again, this is our joint probability function, and this is our joint probability table for this problem. And here again, solving this problem is much easier because all we need is to find the value of the joint probability when x is equal to 2 and y is equal to 1, and plug in the value of c, which we calculated in part 1 of this problem. So 5c is equal to 5 divided by 42 because c is 1 by 42, and that is our joint probability when x is equal to 2 and y is equal to 1. Let's now move on to solve the part 3 of this problem, which is about finding the joint probability when x is greater than or equal to 1 and y is smaller than or equal to 2. Again, this is our joint probability function. This is our joint probability table, and we also know that in order to find the joint probability, all we need is to sum the values when x is greater than or equal to 1 and y is smaller than or equal to 2. So if we look at our joint probability table, these are the values that we need to sum, and if we sum them together we get 24c, and when we plug in the value of c, which is 1 by 42, we get our answer, which is 4 by 7. So this is how we can solve our joint probability problems, and using the joint probability table makes the whole process much easier. So this is all we have in this video. Thanks for watching, and see you all in the next video.